Okay, and back to another video. This one is for writing chemical formulas. I'm replacing the one that I put up last week because it seemed too complicated. Alright, there's some vocab on these slides. If you go to my resources page on my website, you will find the notes for everything here. There's a couple things that I added in during the presentation or the video, but for the most part all of these are here. I'm going to be using oxidation number subscript very often. Also, there's another slide with vocab, superscript, which is the oxidation number and its charge, coefficient, I'll get to that a little bit later, more with when we're doing equations, and binary compound. That's just that's the easier ones, the ones that are just made up of two different elements. There are some that are made up with more. So let's get to what we need to do. Chemical formula. So to write a chemical formula, you need to know certain information. First off, what is a chemical formula? A chemical formula shows how many atoms of each element are in the compound. So CaCl2 is calcium and chlorine, and it is actually called calcium chloride as a compound. I'll get into that in a second. This formula tells me that I have 1 calcium, there's no subscript, so it's an understood 1, and 2 chlorine because of the subscript right next to it. Okay, this does not mean that I have 2 of this total atom. It means that I only have 2 of this, 2 of this total molecule. I only have 2 of this type of element. Alright, so let's go to a page that looks extremely overwhelming. Ionic compounds. Slow down. Okay, so I'll bring the shade up. Ionic compounds. These form because a nonmetal steals a valence electron from a metal. An ion's charge is equal to the number of valence electrons it loses for a metal and gains for a nonmetal. I'm going to go over that on the next page in just a second, but I just want to go over one more thing before I do. Once it becomes an ionic compound, the charge will be 0. That's because the charges of the different elements that come together, the nonmetal and the metal, will need to be balanced out. Okay? To do this, you need to know the charge value of its most common ion. So let's go to the next page to figure out charge values of ions. Okay, so we know that the elements in group 1 have 1 valence electron. Oops, I don't know why that didn't work. Okay, so group 1 has 1 valence electron. Group 2 has 2. 3 through 12 we can't figure out. I don't expect you to know. And then 13 through 18, it's minus 10 from the group number. Okay? So let's start with a very easy ionic compound known as sodium chloride. Okay, sodium, Na, which I'll put right here. Oh, I love this stylus. Okay, so Na, sodium. Shouldn't be that far apart, but you get the idea. Na has 1 valence electron, so I will put that valence electron in the number 1 spot if I was doing a Lewis diagram. Okay, and chloride is actually chlorine, and just to go into this a little bit deeper, when you talk about compounds, the first word or the first element, you say that element for the most part, especially in an ionic compound. The second word always has to end in IDE. The reason for that is because if I just said sodium chlorine, I might just be listing different elements. Because I put sodium chloride, I know that the two things, sodium and chlorine, have combined to make a new compound, a new substance. All right, so sodium has 1 valence electron, and chlorine, I'll make it a script L so it doesn't look like a 1, has much more. It has 7, so I'm doing the shortcut just to make it go easier. Oh my goodness, this is terrible. All right, 3. I need to get what Mr. Sortino has because this does not work well. 4. That's 5, 6, and then 7. Okay, so we have our 2 substances. Don't forget about that. We have our 2 substances that make up sodium chloride, sodium and chlorine. Now, sodium, an alkali metal in group 1, is never found in nature by itself. Chlorine, a halogen in group 17, also never found in nature by itself, or uncombined. That's what that means. So sodium, if it's anywhere near a halogen or any alkali metal near pretty much anything that needs valence electrons, it's going to wind up stealing the halogen is going to wind up stealing the valence electron from the alkali metal in this case, okay? When it steals it, sodium now has one less valence electron, or one less electron than it does protons. So what does that mean? It now has a +1 charge. So back to pin, it has a +1 charge. Chlorine gained one, so it has a -1 charge. Okay? Because that has happened, we now have a positive near a negative. And what happens when you have, opposite charges? They attract. Okay? So you have a plus and a minus, and that is how the ionic bond is formed. Sodium loses an electron, it becomes a +1 cation. Chlorine gains an electron, it becomes a -1 cation. Okay, I hope that makes a little bit more sense than before. So I'm just going to go back to the page that we just had and finish it up by telling you about transition metals. For the transition metals, you'll need to know the oxidation number, which is a charge. It's always going to be positive. Any reason why? It's a metal. That's why. It's a metal. Metals are always positive. I will give you the oxidation number, usually as a Roman numeral written after the element's name. So iron with a Roman numeral of 3 should be Fe+3. Why do I have to write it like this? I will show you right now. So the balancing act. Let's get to that next slide. Well, first we have the ions. I want you guys to write down these ions and then show them to me. Ions of sulfur, calcium, chlorine, potassium, copper, lead, phosphorus, and bismuth. Okay? So based on what I showed you before, you might want to do the Lewis diagram to make it easier, but you look at the valence electrons. I'm sorry, I didn't tell you this one rule, so listen up. If it is less than 4, it's more than likely going to lose those. So 1 through 3, it's going to lose those 3, becoming a +1, 2, or 3. If it has more than 4, it's more than likely going to gain what it needs. So if it has 5 valence electrons, it's going to gain 3, making it a -3. Okay? If it has 6, -2 is the charge. If it has 7, -1. If it has 8, it doesn't need to gain any. If you have 4, something in the 4 area, and then it can gain or lose depending on whether it's a metal or a non-metal. Okay? Non-metals will gain, metals will lose. Carbon is really, really versatile, so it gains and loses. It can be a plus or a minus, but it normally doesn't form ionic compounds. Okay? So figure out these and then see me, and then you'll move on. Okay, so this is how you would write them. I didn't give you the names, I gave you the symbol with the oxidation number. So this is part 1. So with this, you have to cancel each other out. All right, so if the charges cancel each other out just the way they are, a +1 and a -1, you just write it like that, NaCl. If the charges are different, you cross the absolute value of the charge. So the absolute value would be, in this case, 2, in this case, 1. You cross those down and make them the subscript of the other element. So in this case, this one becomes, sorry, I don't have the pen. This one becomes beryllium. I'm sorry, it's not beryllium, it's barium. Barium with a 1 charge. I'm not going to write it because it's understood and you don't write it. So don't ask me, can I write it anyway? No, you can't. You'll get it wrong. Okay? This is fluorine or fluoride now because it's combined, and it has a 2 charge because you're going to cross them down, and that's how you get it. Okay? I want you guys to try these, and remember, if it needs to be simplified, so let's say this was a 4 and a 2. When you cross them down, you still would have to simplify it, so it would be BAF2. All right, I might have gone over that rather quickly, especially for those mathophobes out there. All right, but if you get to it, like once you get to it, let me know. Okay, I want you to do these and show me, and then I have more practice for you on this. Okay, there are going to be other types of ionic compounds that I'll go over in a moment, but what I want you to do is pause here. Actually, I'm going to stop here. So this is going to be chemical formulas part 1. Once you finish chemical formulas part 1, you go on to part 2. Okay? So we are done with this. Once you are finished with this part, you show me and you get the practice worksheet of about 10 problems. All right? See ya.